Good morning. Today I'm going to talk with you about the Airborne Particulates Lab. This is a really simple lab to do, but really super valuable to do. All you need is a bunch of Petri dishes. So that is an initial cost. And blue tape for students, and Vaseline, and stereoscopes. So hopefully your science department has stereoscopes, which are like the microscopes, but they're less magnified, and you have light from the top and light from the bottom. So they're not a light microscope. There are versions of this lab that you can use with a microscope as well. For this one, I use a stereoscope because it's a little bit easier to count than the microscope. If you wanted to use a microscope on the lowest power, you could with these, and the kids would make smaller squares to count the particulates in that square. So what I mean by squares is you'll see that on the next video. I have enough Petri dishes that each student can take home 2 Petri dishes, and then one is a control. So I have groups of 4, so I have 9 Petri dishes per lab group. They come up with a question. So at this point in the year, they've done controlled experiments. They've also done some more experimental design. And so I don't need to check them very much. So on the lab sheet, there are check marks for teacher's approval, etc. And so I check them after they're kind of done setting up the whole experiment, and then they take them home. What they do is they take a tiny bit of Vaseline, and in the video, I made a video explaining how to do this for students. I talk about a tiny bit of Vaseline. What I do is I take Vaseline and I put it on a little index card, and I do one different per period because, and it's just a tiny little glob each period per group, because if you have the same card with the Vaseline all day, or if you give the students this to use all day, there's so much particulates from the air that fall in. I have a very clean classroom. It's a newer building with good filtration, so there's not a lot of dust in my classroom. But let me see if I can get in the sun here. No, I think it's probably better to be in the, see where the light's better and not blotchy on my face. So you don't want this open all day because particulates will fall in here. So they are going to make a control to see how many particulates are in the Vaseline as they make the dishes. So the control here, they're just going to smear the Vaseline, they're going to close it, they're going to tape it with blue tape. On my video, I show regular tape. Change that to blue tape because the regular tape is hard to clean off of these, and then it just leaves behind residue. So I have lots of blue tape. They tape the 2 sides with blue tape, and then when they get home, they just undo the tape, expose the dish, close it back up, put the blue tape back on. They don't even have to have blue tape at home. They just leave it here attached to the bottom of the dish. They come home, they put the blue tape back on. Sorry, I don't have any blue tape to show you. And then they're good to go. And they bring it back to school. So my video shows regular Scotch tape. Don't do that, use blue tape instead. The painter's tape. Okay, and so the control can stay in the classroom closed. And so the control is just telling the students, was there dust or particulates in the Vaseline to start with? So our students, they come up with a lot of great questions. The standard ones is particulate matter higher in the front yard or the backyard, indoors or outdoors. Some kids travel, and I let them do it over a weekend. Some kids travel to other states for like a volleyball tournament or something. So is particulate matter higher in Las Vegas versus Santa Clarita? And they all decide what are your constants. Now this lab is really hard with constants. It's actually a flawed lab, which is the beauty of the lab, because when kids bring back the data and they start counting the particulates, and I tell them, where did you mess up? Because they should have all opened the dishes at the same time and closed them at the same time 24 hours later or 48 hours later. And They don't. They forget. I tell them, set alarms on your phone. but they still forget. And so that's an error. So now you have another variable that's come in. It's not a constant anymore. Also, I say, okay, so the students who did outdoors versus indoor particulates. Did some of your houses indoor have pets and some didn't? Oh, that's another variable. What about some of you live closer to a freeway or a major street? That's another variable. So they're analyzing when they bring in the data that the data is not that good. There's so many other things that influence the data that it ends up being a flawed experiment. And that's why I love this lab, because it's flawed. Because on the AP test, some questions in a multiple choice will describe an experiment and will ask them, where's the flaw? A, B, C, D, where's the flaw? And so they're getting good practice with a flawed experiment with this, but they don't know that going in. Don't tell them it's flawed. The day they bring back data, tell them, did you know it's flawed? Let's talk about how it's flawed. And they figure it out. So with the data, they present it in posters. And the reason why I do posters is because they really hash out the flaws on the poster. So here's an example of a poster. So this is adapted from the book Uncovering, no, wrong one. Oh goodness, forgot the name of the book. But it is an STA book where kids have to make these posters or on little whiteboards about their claim and evidence. I'll think of it as soon as I'm done with the video. But this poster is adapted, and you have the poster template on your paper. So on the poster, kids write their initial question, their initial hypothesis. They have to show their data somehow. I tell them they need to draw a graph either on graph paper and paste it on, or they need to draw the graph on here with a ruler. And then they go through their strengths and they go through their weaknesses. And the weaknesses are the big part of this lab. And they're okay with that. They are okay with, oh, it was flawed. And I tell them, like, why is it important to discover the flaws? And they go, oh, great. I understand. Okay. All right, so let's talk about what if your classroom doesn't have stereoscopes, so you can't get them. You could do, let's say you have a few in the building. I happen to have about 10 stereoscopes, so one per group. But, and those belong to the building, so I just reserve them for that day that we count. Actually, sometimes I give them 2 days to count their data. Because to be honest, it takes them 2 days to count the data and make the poster, and so some kids forget their Petri dishes at home, and so they can bring them the next day and they can add that data to their poster. Sometimes if I have an extra day, I have them present their posters on Flipgrid so they can all talk about it, and that solidifies experimental design even better, but I don't always have that day available. So there are a couple of ways that you can do this. If you have microscopes, what you can do is you can take an index card and punch a hole and put a piece of tape there. And then the particulates can fall on that tape. And it's a tiny little hole then that they can use with the microscope. The problem is that getting it to school and back is a little bit challenging. You have to give them Ziploc bags and hope that the tape doesn't stick to the bag. Sometimes you can make like a little teepee or a little box around the tape, or have them say, I hope, hopefully you have Scotch tape at home, put the tape on when you get home. But then they got to transport it back